This is the story of how a single silicon chip became the most decisive force of the modern era, shaping artificial intelligence, global economics, and geopolitical power at the same time. For decades, power followed visible resources like oil, steel, land, and electricity, but the digital age introduced a quieter dependency: computation. Data was called the new oil, yet data alone could not think, and algorithms alone could not scale. Intelligence needed a physical engine, and that engine was silicon. NVIDIA did not invent artificial intelligence, but it built the machines that allowed intelligence to grow beyond human limits without drawing attention. What began as a gaming company focused on rendering graphics accidentally solved a deeper problem: parallel processing. GPUs were designed to calculate millions of pixels simultaneously, but neural networks needed the same capability: massive parallel calculation. While consumers saw entertainment hardware, researchers saw the future of machine learning. NVIDIA was already positioned years ahead, while competitors chased traditional CPU performance. In the first 5 seconds of every major AI breakthrough, an NVIDIA chip is running silently in the background, training models, recognizing patterns, simulating reality. From speech recognition to autonomous driving, from medical imaging to large language models, this revolution was not driven by clever software alone. It was constrained and enabled by hardware. Ideas were plentiful, but computation was scarce. The next 25 seconds explain why almost no one noticed until dependence was complete. Governments focused on regulation, startups focused on applications, investors focused on valuations, NVIDIA focused on infrastructure. By the time artificial intelligence became commercially critical, the supply chain was locked. Ecosystems were entrenched and alternatives were theoretical. This was not luck, it was a long strategic bet that intelligence would eventually demand massive computation, and when that moment arrived, NVIDIA would already control the tools. It quietly reshaped markets, research timelines, military planning, and national priorities before the public realized intelligence had become an industrial resource. This shift marked the true beginning of the AI gold rush, and no one was prepared globally. NVIDIA did not secure its dominance by selling faster chips alone. It did so by building an ecosystem that quietly reshaped how artificial intelligence was developed, deployed, and scaled. In 2006, the company introduced CUDA, a software platform that allowed GPUs to be programmed for general-purpose computing. At the time, this decision appeared technical and niche, but in reality it was strategic and irreversible. CUDA changed the identity of the GPU. No longer just a graphics accelerator, it became a computational engine. Researchers quickly realized that neural networks performed dramatically better when calculations were executed in parallel. NVIDIA offered not only the hardware but the tools, documentation, libraries, and long-term support required to experiment safely. Universities adopted CUDA first because it worked reliably. Students learned it by default and carried that knowledge into startups and corporations. As artificial intelligence moved from laboratories into products, the inertia became overwhelming. Startups built their first models on NVIDIA because their engineers already knew the stack. Cloud providers standardized on NVIDIA because customers demanded compatibility. Enterprises followed because risk mattered more than cost. Switching architectures meant rewriting code, retraining models, and delaying deployment, sometimes by years. Competitors attempted to respond with faster or cheaper alternatives, but speed alone could not replace maturity. NVIDIA controlled drivers, optimization pipelines, debugging tools, and developer trust. It was not just selling performance, it was selling predictability. In AI, predictability determined survival. As demand accelerated, GPUs became scarce. Training a single large model could require thousands of units running continuously for weeks. Delays were measured not in hours but in lost market leadership. Chips once marketed to gamers became strategic assets negotiated at executive and government levels. This created a form of dominance without aggression. NVIDIA did not block competitors, it simply became unavoidable. The deeper artificial intelligence integrated into business, science, and defense, the stronger the dependency grew. What appeared to be a semiconductor supplier had quietly become infrastructure, and infrastructure once established is extraordinarily difficult to replace. Every gold rush rewrites the rules of power, and the artificial intelligence gold rush proved no different. Capital moved faster than understanding. Startups promised intelligence in every product, investors chased exponential growth curves, and governments announced national AI strategies with urgency. Yet beneath every vision document and funding announcement lay the same unspoken constraint: compute capacity. Cloud giants depended heavily on NVIDIA while publicly signaling independence. Product launches, internal roadmaps, and research timelines were quietly shaped by GPU availability. When supply tightened, innovation slowed regardless of ambition. Models could be designed but not trained. Breakthroughs existed in theory but not in execution. Intelligence became limited not by creativity but by hardware access. This created a new hierarchy of advantage. Nations with secure access to advanced chips gained strategic leverage. Companies with priority contracts moved faster than rivals with equal talent. Smaller players were locked out not because of poor ideas but because they could not afford the compute required to compete. Artificial intelligence shifted from an open research field to an industrial capability. Critics warned about concentration risk. One supplier meant one failure point. What happens if progress bottlenecks at silicon? NVIDIA responded by reframing its role. It positioned itself not as a chip vendor but as the operating system of AI infrastructure. By offering integrated hardware, software, and deployment solutions, it reduced friction while increasing dependency. The contradiction became clear. AI was marketed as democratizing intelligence, yet its foundation was one of the most centralized supply chains in modern history. The true winners of the gold rush were not the miners building applications but the toolmakers supplying the machines. Just as railroads defined industrial empires and oil pipelines defined the 20th century data centers filled with GPUs, now define influence, simulate markets, weather biology and warfare. NVIDIA sits at the center, not directing outcomes but enabling all of them. In the modern era, power does not need to be loud, it only needs to be essential. The final question is no longer whether NVIDIA shaped the artificial intelligence era but whether its position can realistically be reversed. History shows that once infrastructure becomes foundational, it does not vanish, it fades into normality. Electricity no longer feels revolutionary, roads do not inspire headlines, and yet nothing functions without them. NVIDIA is moving toward that same invisible layer of necessity. As competitors design custom chips and governments fund national semiconductor programs, the challenge is not innovation but momentum. Ecosystems are slow to rebuild. NVIDIA has spent decades cultivating developers, software stacks, deployment pipelines, and institutional trust. Replacing hardware is achievable, replacing an entire workflow is not. Artificial intelligence systems are trained, optimized, and deployed around NVIDIA architecture, and that dependency compounds with every new generation of models. Recognizing this, NVIDIA no longer frames itself as a chip manufacturer. It positions itself as an AI infrastructure company. Simulation platforms, digital twins, robotics frameworks, autonomous systems, and enterprise AI factories are not side products, they are anchors. Each layer increases integration and reduces exit options. This is not expansion, it is entrenchment. Modern power rarely announces itself, it stabilizes through necessity. Researchers may write algorithms, but NVIDIA defines the conditions under which those algorithms can scale. Governments may regulate applications, but compute remains the true gatekeeper. Intelligence in theory is limitless, but intelligence in practice is constrained by physics, energy, and manufacturing capacity. The AI gold rush is still accelerating. Larger models demand exponentially more compute, and the distance between imagination and execution continues to widen. NVIDIA operates precisely in that gap, supplying the machines that transform ambition into reality. Years from now, the world may forget which model launched first or which application went viral. What will remain is the structure that made intelligence industrial. NVIDIA did not predict the future. It positioned itself where the future had no alternative path forward. That is how quiet dominance endures.